All right, welcome to part 3 of lab assignment 6. And before we kind of go ahead and with the last part of the assignment, I just want to show you, so these are the techniques that I showed earlier in parts 1 and 2 of the assignment. Basically are some of the techniques that I used or I've used in the past to build sort of projects like this, right? These curvatures are relatively complex, but things like this that are important in terms of maintaining a sort of constructible radiuses or radii, blends in between, making sure that dimensions or curves are things that can be dimensioned and basically constructed, right? And these are all built up slowly from very simple commands, whether it's the sort of filleting surfaces, lofting them, but with a certain sort of rigor that allows you to do something like this. And the main thing is that these are basically done for constructability, because if I do, let's say, a curvature analysis on this group, and you'll see that the green here, if I do an auto range, basically says that okay, all of these are, besides the sort of one-dimensional curvature or one-sided curvature, single curvature that can be produced by rolling steel, basically. All these are flat panels, right? Even given their sort of fairly complex shape that you see in 3 dimensions, right? These are all single curvature panels that can be easily fabricated. So you'll see that when I do a zebra stripe analysis on both like the canopy and the sort of side panels, you'll see that the zebra stripes will always actually follow the direction of the curvature geometry in this case on the bottom part, right? But on the top part, obviously, then because this is actually doubly curved, right? This is, the zebra stripe is sort of like a mirrored surface. So when I move it around, you'll see that, okay, the zebra stripe actually shows you that these surfaces are doubly curved, since this is actually meant to be somewhat of a tensile fabric. But when you go into something like, actually, let me turn the zebra off. When you go into render mode, then you'll see that these surfaces are seamless and smooth, right? So this sort of just depends how well you kind of build your geometry and your curvatures to make them rational and buildable in the end. Okay, so that's just an example of things that are slowly built up over time with precision, actually just using a lot of these techniques that I just showed you in parts 1, especially part 1. A little less in part 2. Now the part 2 that we'll actually be looking at, techniques in part 2 that will sort of segue into part 3 that we're going to look at are actually parts of this. So this is the EPFL project in Lausanne, Switzerland by SANAA. A Japanese firm, Japanese partnership that actually, I would say that this project is actually one of the projects that actually won them the Pritzker Prize in 2010. So actually, I think I have their website up here somewhere here. Okay, so the 2010 Pritzker Prize, SANAA, Ryue Nishizawa and Kazuo Sejima. In a lot of their projects, they have lots of beautiful projects in the Rolex Learning Center at the EPFL, École Polytechnique Fédérale in Lausanne, Switzerland, is actually one of their sort of flagship projects, and you can see a lot of the pictures here as well, right? And this project, as you can see, in its plan and its section, it's basically a sort of undulating surface landscape with these sort of holes cut out into them as a sort of continuous topography, right? So you can sort of actually see the similarities here, and we'll have these sort of images online between that and the sort of way we actually manipulate or work with something like this. Okay, so part 3 will actually, we're going to replicate in some ways the EPFL or the Rolex Learning Center, not one-to-one, but just sort of trying out some of the techniques that will allow you to do something like that. Okay. And while that project might seem to be really complex, once you kind of understand some of the basic operations, it's actually pretty simple. So what I want you to do is actually sort of come back to this rebuilt surface that you had, and just sort of copy it out somewhere. Doesn't really matter. And we'll use this as the sort of basis for part 3. So same thing. Just use F10 to turn on your edit points. And I think this should be different for everyone, but you know, just sort of give it. Doesn't have to be too much. Give it a little bit of surface undulation, sort of in different ways. So I don't know, just sort of try messing around with it, lifting different corners. It doesn't have to be too exaggerated, and you can kind of have, you know, maybe a little bit of gradation here and there, so you can sort of slowly decrease your selection set. Okay, just so you have something like this, right? And it doesn't have to be really sort of super precise. Okay, and we're just going to use this as a basis. And instead of, you know, if you looked at the plan, there's many holes in that project, or many openings in that project. But for our sort of purposes, we're just going to do maybe 3, right? Okay, so let's actually just sort of establish a floor-to-floor height. So copy vertically. Let's see how much. Let's say what looks reasonable. How about 14? Okay. So this will be kind of like our sandwich, right? That's the floor, that's the roof, and everything else sort of goes in between there. Before we do that, I'm going to organize my layers a little bit. So I'm going to make a TMP layer out of the red, make a floor, or actually let's call it slabs, out of this purple, out of this green, blue, it's called glass, and actually I'd like to make my glass lavender. Make my slabs maybe dark gray, and then I'll make one that's called mullions, maybe. Oops. Mullions. All right. Yeah, green's fine for now. Okay. I'm actually going to put these on the temp layer. So change object layer to temp, right? Make my slabs layer active. So let's see. I'm actually going to switch to the top view and go find this, right? And I'm just going to draw a circle somewhere. Doesn't matter, as long as it's decently large. Somewhere here. Actually, these all should be on the temp layer as well. So make it on the temp. Change object layer. Draw a circle. Draw a oval. So here, I think this is an ellipse, right? And let's make it a little bit narrow. Okay. And you can obviously sort of move around, adjust it, or even make it larger after the fact. Now let's make it a little larger, something like this. And then a square somewhere. Let's do it there. Now note I'm sort of being careful not to snap to the surface, so I'm clicking in empty spots. The reason being I want, eventually, I want these things to be on the ground, right? I want them to be on the XY sort of plane. And now these two, I'm just going to move them up. It doesn't matter, arbitrary distance. Okay? All right. So these are actually going to be what I'm going to use to do what's basically the sort of Boolean or cutout operations for the floor slabs. But this is going to be the sort of floor-to-floor height. So let's actually switch over to the slab layer, and let's take this and let's say, and actually offset surface or extrude surface will both work because these are going vertically. So offset surface, corner sharp, distance solid, distance 2, yeah, 2, maybe a little too thick. Let's do distance 1.5. Okay. And one of the options you're going to have to pick is to not delete the input here, right? So don't delete the input, and that will give you this, right? So you have the red layer down here and the sort of slab layer down up there. Same thing for the bottom one, except we're going in the other direction. So we're going down. So you want to flip it. So you're going down. Same thing. Don't delete input. Delete input equals no. Distance equals 1.5. Solid equals yes. Okay. There's a reason I'm doing this, because this sort of red surface I still want it because I'm going to use that as my trimming plane for things later on. Right. So now I'm actually just going to hide these two red surfaces. Hide. So they're not in the way. Okay. All right. So I'm going to take those sort of three figures that I drew on the ground. I kind of drew them in the plan view, right? So you can sort of organize or arrange them however you want. Extrude it upwards as a solid. Okay. And as you might have guessed, let's Boolean difference them. And to subtract from these two slabs, right? To subtract with these three volumes, and you should get this. Okay. Well, that's simple and easy. So if we look at the pictures, there's these sort of glass mullions that kind of run the edge, and if you look at these sort of interior courtyards, like there's glass, there's sort of column / mullions, and sort of we're going to try to replicate some of that a little bit, right? But usually this is sort of inset a little bit back from the edge, and so we'll have to actually do a little bit of stuff to actually be able to kind of do that, and I'm going to show you how to do it. So here we're actually going to try to get the glass first. So let's show our red planes back again, and I'm going to take one of these and actually just project it to C plane without deleting it, so it's still there, right? And then I'm going to duplicate the face border, of that rectangle, and then delete it. I was doing it just for the boundary, right? So I could get this and then change object layer, so it's on the temp layer. Okay. So what we're going to do is we're going to offset it inwards a little bit. So let's say offset, normal offset. Distance, let's see, 0.5 might be, oh, it's decent. Okay. Let's see, 0.5. Let's actually do distance equals 1. So I'm offsetting it inwards 1, and it's a little bit exaggerated, but whatever. It's still on the temp layer. Okay. And let's just extrude it upwards, not as a solid. So solid equals no. Do that. This actually will be on the glass layer. So change object layer, right? And you'll probably see where I'm going with this. So I'm going to take this surface and this surface, the two sort of red surfaces, and I'm going to use them to trim off the top and the bottom. So I get this, which is basically the sort of continuous glass box going around it with a little bit of setback, right? Okay. So that's pretty simple and easy. But well, let's hide this. The hard part is actually these, because these, then we have to do the same, right? And so offset, surface, oh, oops, sorry. Offset, normal offset, and all of these, except I want to go outwards in this case, right? And this one too, and this one too, okay? So you can select them and change them over if you want. All right, so let's take those outside offset profiles and extrude them. Same thing. You can change them to glass if you want. Take those two cutting surfaces to trim out top and bottom. Okay, so I mean, you have to be careful of this, like I'm using the sandwich, right? So these actually only extend to the inners of the slab. And if you turn off the temp layer, then you'll get something similar to this. Probably better in ghosted mode. Alright, so there's a little bit of offset inwards from the slab. You have the glass sort of meeting at the right places. Okay, alright. Now, we are going to do the mullions, okay? So any of these, sort of quick and easy way. The one realization you have is that the distance between any of these points, as long as they're perpendicular, should be the same. So here to here, it's always 14. If I pick any of these points here, from here to where it meets at the top of the slab, it should be 14, right? So anywhere along these lines, along this line, as long as it's vertical, the distance should be 14. Okay, so that's the one main thing to know. Okay, so let me show back this glass box, okay? And we're actually just gonna draw, and let's use the mullion layer for this. And we can do, well, we can do the pipe. Let's do the pipe. So draw a line from top to bottom, basically at the corner here, right? So this is a simple line, and let's pipe it. Radius, let's try 0.5 and see. That's a little too thick. Okay, so let's try 0.3. And okay, that seems a little better, but .25. Enter, whatever. All right, so that looks okay. Okay, so using that, and you'll kind of have to guesstimate like how many you want, right? So, so let's, I don't know, let's try 8 or 10. But basically, I'm going to use the ArrayCrv command. Select objects to array. Select this, the pipe that you just made. Enter when done, and select the path curve at the base point. So I'm actually going to select this curve that is the lower edge of the glass. Okay, number of items, let's say 8. Okay, and the problem that you see with the ArrayCrv is that it does this. Okay, so let's go back one step and do the ArrayCrv again. ArrayCrv, select objects to array, enter when done, select path curve here, and make sure you change the orientation to no rotation, and then you'll get this. All right, so that looks kind of reasonable for this side. And you basically rinse and repeat for the other sort of sides. Path curve, let's say 6. Path curve, 8. All right, and so you can understand it's really easy to do the same for the interiors, except you can just like take one of these guys, copy it over. And to kind of make that easier, you might want to hide the slab layer, right? And you can pick one of these guys, copy it using this sort of center corner point. And in the terms of these, it's easy to kind of snap to the seam, right? For these guys, it's sort of easy to kind of snap to the seam, and this is easy to snap to one of those corners. And by using the ArrayCrv, I mean this, you can maybe just sort of actually just copy them into place. But this is so close that I don't know that maybe you just need one there. But for these, you can kind of guesstimate. So ArrayCrv, select objects, the pole, path curve at the base point, and then let's guesstimate 12. Right, and just does that right away. ArrayCrv, objects, path curve, or you can say you want to do a specific distance between items. It might not divide it perfectly because of that, because then you might have, let's say if you do 8, then you'll have this, right, where you get one that's really close in between. If you do the distance version. So base point, let's do 10 for this, right? But if you do the number of items version, then it will always sort of equally divide it for you. So there's sort of advantages to using that. Right, this guy, I mean, basically you can just, I think, just snap it to the corners. And there's probably one in the middle here. So I'll place one at the midpoint of both of these ends. And this is probably 2 or 3, so I'll do the ArrayCrv. Enter path curve at the base point, and let's do 4. And because I'm doing this, you'll notice that I get a duplicate here, right? Because the 4th one actually is in the same place, so don't forget to actually take it out. ArrayCrv, object, path, okay, and then this guy on the end is a duplicate. It's easy actually to select duplicates if you go to your selection sets. This, where is it? This guy here, select duplicate objects, select dupe, and it will tell you, do you have any duplicate selection? So there's something here. This got duplicated. All right, that's it. Get the slab back. Everything else is on that temp layer. That is just for construction geometry. And you can maybe move this back so it's sitting on the ground. I sort of lifted it up so it's easier to kind of model and look at the stuff that's below, right? But you can easily do that. And remember, when you're not sure what the sort of lowest point, at least in this case, it seems like the lowest point is here, but if you're not sure what the lowest point for whatever geometry you're trying to do is, you can always run the bounding box command, enter, right? So it gives you basically the bounding envelope, and then use that and move it vertical, move it down, move vertical, right? Vertical, and click on that corner, whoops, vertical, click on that corner, snap it to that, right? And then you can delete the bounding box afterwards, right? So now it's actually sitting on the XY plane. Now you can hide this, and you have a mini Rolex Learning Center. Now, you probably to get into the spaces, you have to change your perspective angle to something much wider. But let's say, yeah, so you can actually get in here. All right, so it's not exactly a one-to-one replica, but it's a pretty, I think the sort of general idea is very similar. In the real building, though, while the bottom is actually poured in place reinforced concrete, the top is actually done out of a series of wooden beams. And so you can actually do that very quickly or very easily. Let me do it on this sort of third layer and make this, let's say, orange. And beams. Okay. And just by doing the contour command, select objects for contours, select any of these corners and just sort of drag it in the sort of perpendicular direction, actually this way, right? Distance between contours, let's do 10, maybe, nah, 15. Oh, too big. Okay, let's try that again. Let's do 5. Right? So this actually automatically gives you the sort of section cuts of those beams, right? Just so you can see that, right? And usually when it's there, while it's still selected, I join them all together because when you do the contour cuts, they're not joined. But once they're joined, then it's really easy to use the, oops, what did I just do? It's easy to use this, right? Surface from planar curves to substantiate them into ribs and or give them thickness. Okay, so that's the sort of idea of part 3. And you know, I think because everyone's surface is going to be different and configuration is going to be different, but you should have something that roughly looks like this. And that's it.